what you have experience with this case study method, maybe in one of your class for undergraduate, for example, or in a postgraduate class. And I think we can start because it's sorry, the participants, it's 20, but maybe by the time it will be more than 20, because the registrant more or less I think more than 100.
Okay,
So
no problem.
we start this seminar.
Yeah, I think we can start, right? If you are ready, I'm ready.
Yes. So
okay.
on behalf of the Department of Metallurgy Engineering, Faculty of Engineering, Sultan Ageng Tirtayasa University, I would like to welcome Professor Paula Vilarinho from Universidade de Aveiro in Portugal, and also for all the participants that join with us this afternoon for more or less 2 hours for the presentation and maybe discussion between Prof. Paula and the audience. I just want to introduce briefly Professor Paula Vilarinho. She worked at Universidade de Aveiro in Portugal and joined with the CICECO at the university, and has a group research. It's called electroceramics, and maybe in one of this electroceramic class, maybe Prof. Paula will present us the example of the case study. So please, Professor Paula.
Thank you very much, Aditya, Professor Aditya Trengono, for this invitation. This is the second time that I'm somehow interacting with you and your university, and I'm very pleased to do that. Unfortunately, I would prefer to do it personally, but since it's not so easy, I think these Zoom facilities are really, really great. This is also a challenge for me because we are not using on a regular basis this project learn-based or challenged based learning, not very often. And I'm very interested on that process of teaching and learning, and I really believe that when we do it, we engage more the students. So I think that's a very interesting challenge, and I think I will defend my case. As I said, University of Aveiro is now very involved in this challenge-based learning, and I will explain why. And myself, currently, this semester, I'm teaching 2 classes in which I'm using the challenge-based learning, and that's I'm going to share with you a little bit of the principles, and then a little bit of what we are doing in terms of teaching, but also in terms of research, because we are also using this challenge-based learning in our own research. And the case I picked is exactly a research exercise that I'm currently doing as a researcher, not exactly as a professor. So I always like to start with this slide, in which intention here is to show that I think when we have a challenge to solve, we are more engaged and we learn. I think we learn faster and we learn better. That's my point of view, and I think this exercise is really interesting. So I'm going to move my slide. Just give me just a minute. Sometimes these slides take a while. Why is this not moving? Just give me just a minute. Yes, now it's moving. So the title of my talk, and I said I really am grateful to the opportunity to share some of my ideas, is called Challenge-Based Learning. That's the process we are using. And in this case, applied to engineering courses, because as you know, you can apply this to many different situations. In my case, it applies to engineered courses and also is applied to research, as I said. So I'm Paula Vilarinho. I'm coming from the University of Aveiro. If I have time by the end, I will present a little bit. Some of you maybe know already. I'm coming from the Department of Materials and Ceramics Engineering and from CICECO as well. That is one of the, I would say, research centers of the university. As Aditya said, and very well, my main research area is electroceramics, and I think that my case study will somehow reflect a little bit of my field of research. Just give me a minute, maybe. Okay. Yes, so I need to go back. I organized my presentation in four main aspects, and the one that really I feel that is challenging me as a person, and should challenge all teachers in the world, because there's a lot of challenges associated with this. I would say the 21st century, and the way we learn as even as children, young adults, or even as more mature adults. Then I will really describe the challenge-based learning principles that we are using, and this is one of the ones that we are using. And the reason is somehow related to the fact that we belong to the SEU, the European Consortium of Innovative Universities, and my university is very engaged in it currently and really taking a lead role on this challenge-based learning. And then I will pick up one example. An example, just to let you know the methodology and what we are doing, I pick up the example of the ocean. And I will explain why the ocean and what we have been doing. And then I think I will conclude. So I think I will not be talking for 2 hours, but I will leave you my experience, my current experience. So let's talk a little bit about the challenge of the 21st century. I think everybody knows that teaching currently, it's not easy. The reason why I embraced the challenge-based learning, the first time they presented me as a different methodology was related with the fact that I don't feel that my classical teaching is really pleasing my students. And this is a process of teaching, but at the same time of learning. So there is two things here. I teach, but my students need to learn. Otherwise, the process is incomplete. So currently, it's really challenging to be able to teach on a very classical way. And the reason, I think, is really mentioned here. I think it's more or less clear to see that 21st century learning, there are these three major influences that really will be present in the process of learning. So we live in a world that is completely globalized. we live in a world in which the technologies and innovations are there. And we live in a world, sorry, I have to, yes, sorry, because my slides. Okay, and we live in a world that people learn with very different tools. And I think that's exactly what we are facing at the universities all over the world. It's not in Indonesia, or it's not in Portugal. All over the world, we face the same situations. So if we are able to understand how people learn, the students and ourselves, researchers, that we live in a globalization time, and that we have technology that are available to us, I think that we may do something interesting. And that's what I feel that is the challenge-based learning. Challenge-based learning was developed by a company called Apple. And the reason why they were developing this process was based on their needs. And there's another important word that I think I will use along the time, is there is a need. And if there is a need, we can fulfill it. Okay. Other reason is this interesting. You see, I have here my notes where I take this from. And I really like also this image. And I think that we all, and students are all the same all over the world, they learn, if they wish, they learn. And I think one of the things we need to do is really creating on them the conditions for them to be challenged. Because as young adults, as young researchers, they have an enormous potential to learn. But really, the conditions in which we live currently, they need to be challenged. So if you look at this graph, it's interesting. If you see, we may have very different strategies for them to learn. And if these strategies, and can be multiple strategies, but if there is no complexity in learning, it's just strategies. So students or listeners become very bored. However, on the other side, if the topic that we are learning, that you are teaching or learning, it's very complex and we don't get it, we get frustrated because our learning is not going smoothly. However, if we mix a little bit of complexity, that is something that our brains are trained to solve, and different strategies, this really gives us a kind of a flow of experience, and where the creativity becomes very important. Okay, as I said, I'm using these different methodologies to teach engineering course. So what we are doing, we are preparing the engineers for the future. And I think that in this global world, it's very important that engineers be highly creative. So I think that the universities have the obligation to implement technologies that foster the creativity in our students, in our, I would say, in our future engineers. And the challenge-based learning, in my opinion, is doing that. So if we also, we have a lot of information coming from the students. So we know exactly what the students think. The majority of the universities knows very well what is the feedback of the students when they finish learning. And there are, I think, two big categories of the learning process. One of them, they call it, these are the people that really study and do science about learning. There is the deep learning and there is the shallow learning. And the shallow learning, as we know, is simply memorizing. This happens to me. So if I memorize, maybe 2 or 3 days after, I can't remember a single thing that I memorized. However, if I make relations That's the way our brains work. We make relations, we make analysis, and then I'm able to discuss something, to understand something. So that's this. I think we all know this. So deep learning also requires that we use evidences. So if we use evidences, if we really use cases that are real to our world, to our experience, this is much easier than understanding things that they don't tell us anything. And that's the natural process of learning of the human brain. It's nothing very special, I would say. And the other thing is that we do not learn suddenly. We become good learners. There is a growth. There is a steady increase of learning, of getting information, and being able to digest and use this information. And the other thing is that, as my students always say to me, this topic does not say anything to me. I don't like it. You know, they say like that. So it's very difficult because I don't see myself in this topic. There's nothing of this topic that relates with me. Okay, so I think here we have also some ingredients of the way we should be teaching and the way we should be learning, because I think we also, as professors and researchers, we also learn. Okay, so within this context, I think that the challenge-based learning developed by Apple Macintosh in their facilities. I think they were looking for bright engineers, and they challenged them to develop products. That's where this started, and this can be very, very, very well used at the universities. Okay, so here is the process, and that's the way they develop it. It is divided in, I would say, 3 main parts, and they call it engage, investigate, and act. And I'm going to go through these in detail one by one. So in my opinion, challenge-based learning is really an effective learning framework that was initiated at Apple, and this can be used universities, schools, institutions, research around the world. And I will give you my own example of something that we are currently doing. And it's really using the tools that we have available now, and the tools that are competing with us as professors, as teachers, because maybe in your university, like in my university, all our students have mobile phones. So all our students are connected to the internet at every second. Some of them are better than us in using these technologies. So immediately they get answers, immediately they get informations, etc. So using these tools, I think that we can teach them and they can learn. And this can be used as a lifelong experience, because this then later will make even an impact on their own life, in our case as engineers or researchers or whatever. So the really framework of challenge-based learning is, I would say, the key aspects are associated with this first step, that's identify a big idea and something that really needs to be solved. Okay, and this is the reason why in my example we picked up the ocean. You will understand why. Then the other aspect is ask good questions, because if we do not ask the right questions, we do not understand what is the need. And talking with people, with different people, we should involve the full chain of the stakeholders, people that is involved in that idea from the beginning to the end, then we may have the complete knowledge of what really there's a need. These big ideas should be something that we call societal, should be something that really engaged all of us and have a societal, I would say, responsibility. And we should be able to enroll the students in this challenge. Okay, then after asking the good questions, I think that we have a panoplia of challenges, a lot of challenges, and what we need to do, because we cannot solve the problems of the world in one day. We should identify and pick up the challenge. Then we should go very deep in the knowledge of that subject, and then using these 21st century skills and everything that is available, we should try to present a solution to that challenge. And of course, then by the end, the methodology says, now that you have an idea to solve the problem, you should share your thoughts, you should share your ideas with the world, so you should present it to the world. I think if you deeply think on what is written here, and as I said to you, this was developed by Apple Macintosh company, this is what we do on a regular basis. And that's really the way our brain works. We are excited as human beings to solve problems. I think we naturally born to solve problems. That's what differentiates us from the animals. So when we are teaching, if we really change the students to solve a problem, I guarantee you that they are much more engaged. So it's really a very interesting example. But I will also show you that although the students that I'm teaching are very young, at the beginning, they react. So at the beginning, they don't like it because they don't understand it, and because we are doing something different than what they are normally doing. So they react, they don't feel very comfortable, but after some time, it's really impressive what students can do. So we are very into this technology. So of course, that's there's a methodology, and if we don't do it properly, then we will maybe not succeed. But the base and the key aspect of this technology is that really they learn, and we learn by doing, and that's the reason why I decided to share with you what I've been doing these past weeks. So again, the process of challenge-based learning has three main phases. The first one, it is called engage. The second one, it is called investigate. And the third one and last one is called act. So in my classes, the classes are divided precisely in these three, I would say, parts. And after each part, the students are evaluated. And this gives us an idea how they are progressing. And in this evaluation process, they are evaluated by me. They are also evaluated by colleagues that I ask to come and to talk with them. And they do also a self-evaluation. And it's quite interesting because this obliges them to be responsible also and to analyze them as well. Okay, so let's go step by step in each of these phases. So what are we doing in the engaging phase? So during the engage phase, the learners are really moving around something that is still abstract, that is really a big idea. And the example I'm going to show later is the ocean. The ocean is enormous. So what is the challenge associated with the ocean? And then when we engage in the topic and we start questioning and talking with the right persons, then the needs, I would say, the challenge start to appear, and we are able to define what are the big questions to be solved, and then we are able to identify a challenge that we want to solve, to which we can contribute. Okay, and the key aspect here is really to connect. It's really to talk, to engage personally as a person, understanding that really there's a challenge, but also engaging others and selecting the right stakeholders and ask the right questions to understand. And that's one of the most difficult exercises, particularly for the students that are shy. And currently, as you know, your students, as my students, your researchers, as my researchers, they use internet for everything. Some of them are not able to, or not easily able to communicate, pick up a phone and make a phone call, go to a company and ask questions. Sometimes this is difficult for them. Okay, so after getting a big idea and getting a lot of questions about that topic, then and involving everything that is around you, then you start, I would say, fractioning this big idea and different challenge, and then you start seeing where you can have a contribution and where is a problem that you can solve. And there's a lot of examples of big ideas that you can challenge your students to solve, depending on the topics that you are working. And I'm remembering you. So these are the most common given examples, like a community or relationships or creativity or health or sustainability or democracy. The one I'm going to share with you is the ocean, because the ocean is important to us, okay? So that's the big idea. So what are the challenges associated with the ocean, and what should we do to solve these problems of the ocean? So essentially, the key aspect is really asking the right questions. And you will see what are the questions that we are asking associated with the ocean, right? So ask the right questions. First, to yourself. In our case, is the ocean important to us? Of course it is. Are there problems associated with the ocean? There are a lot of problems associated with the ocean. How does research can help to solve this problem? A lot of the developments in this century will be based on research and knowledge. So of course, there is an opportunity for us. So by the end of asking all of these questions, we are really able to identify the problem and being able to select a challenge. It's not an excellent idea to try to solve all the problems of the world at the same time, right? So we need to find one in which we are really able to contribute. So this challenge becomes really an essential question in which we need to really learn more, learn and learn and learn. So the first phase of the process is really the engaging. Engaging usually, I say, by identifying the big idea, ask the questions to all the stakeholders, identify where are the problems, and choose the challenge that you are going to respond to, okay? And this is indeed what is the first phase, engage. So a big idea, essential questions, and then defining the challenge. Then we go to the investigation phase. Investigation phase is, okay, I should go back and say that after the engaging phase, if we are doing this exercise with students, and this is this normal class of our courses, they will be evaluated at this phase. And they will be evaluated on their ability to really chunk the big idea, in the quality of the questions they did, in the quality of the stakeholders they involved, in the quality they interact. So they have to document step by step what they have been doing. And, you know, this is a process that goes beyond the classroom. It's not exactly in the classroom that these things take place. They have to go to the world and they have to interact and engage with all of the parts. And then they will identify the challenges. Usually they discuss this with us. Okay. Second phase, investigate. So what they have to do, what we have to do, we have to learn as much as possible about our challenge. The example I'm going to give again is the ocean. So I've been learning a lot about the ocean because my research field is not the ocean. So they really need to learn deeply about the topic they are trying to contribute to the solution. So some of the things they will learn deeper, some of the things they will learn not so deep, but they need to have a good research based on the topic. So they need to read scientific papers, they need to read the open literature, they need to read patents, they need to really dig about the problem, trying to look what are the companies doing things to solve this problem, what are the challenges they are really needing. They really need to be quantitative, associated and rigorous, associated with the information they can gather. So here is really a moment of reading and analyzing and collecting information, making big maps to know, oh, about this topic, the world currently knows this. And then they really have a kind of a knowledge platform that allows them to find a solution. Because sometimes if we don't really dig deep in this, I would say, investigation, that's the reason why it is called an investigation step. We really need to know what are the possible solutions and sometimes even solutions in other areas in which we can bring in to solve the problem. I will quantify this in the example I'm going to give. So there are, again, a question of a list of questions that we should answer, and we should really investigate to be able to find answers to the questions that we got from our challenges. So I will stop here by remembering you that there's a big idea. From the big idea, we question until we understand that there is a challenge to solve. So we identify the challenge. Now we need to have the proper questions that should be, I would say, questioned and to find the right answers to solve that challenge. So, and this needs to be done based on the knowledge that we are acquiring. And then there's something also interesting, is that we got a lot of possible solutions for that problem, for the problem that we are tackling, for the problem that we want to solve, but we need to categorize them. Which one are more important? Which one are more relevant? And then, because during this process, since we cannot solve the entire problems, we need to prioritize. And at least in our students, prioritizing is not an easy task for them. It's not also an easy task for me in my research life, but it's something that really we need to engage with them, to guide them in the process, to say, look, you have a lot of things that you may do, but there's one that is more important than the other. So categorize them and prioritize them. And I think that's another thing that's really is quite important. There's a lot of also things that I mentioned to you that they really use quite well. There's a lot of blogs. There's a lot of the social networks. There's a lot of things ongoing in the internet. There's a lot of online contents and courses and databases and things that they can really tackle. Here I should say that when we do challenge-based learning, our students work in groups, because this is very challenging. Just one student, two students, it's really very difficult to done, because there's a very high amount of information that they need to acquire, digest. So this is also a very good exercise to do in groups, because usually we find a team leader in a group. So I'm working currently with groups of five students. So there's a team leader, and the team leader needs to report every week. And the team leader needs to guarantee that all members of the groups are doing tasks that are not overlapping, because every member of the group needs to contribute. And as you know, sometimes with students, things does not go the way we think they go. So it's important here. The other comment here is that they should use all of these resources. They should also read scientific papers and read patents. This is an engineer course, so we are looking for concrete solutions. This means that they really need to start reading patents. Many people, many researchers don't do it. And in patents, there's a lot of solutions, and also solutions that could inspire you to your own problem, okay? So I have a student that always says that solutions for all the problems are in the internet. If you really dig, you will find the solution. This student is quite interesting, okay? So other tools, simulation, sometimes they need to do experimentations. Sometimes they need to really do, you know, even gaming, because there's a lot of simulations that look like gaming that they can use to simulate, and we are using this in the case of the ocean to simulate the currents of the ocean and things like that. So it might be really interesting, and it's really the phase in which we as researchers and scientists go and students go deep in understanding and acknowledging. And when you read and you think, other questions will appear for sure. Okay, so when we reach this part, there are reports and also presentations from the students. So another moment of evaluation is when they really reach the investigation part, in which their brains say, I have a lot of solutions for this problem. Okay, so all of them participate in this process. They have these guiding questions, so they have to elaborate the questions at the first beginning. So here a key aspect is really asking questions, and when we ask questions we are thinking, right? And then guiding all the activities in order to be able to respond to these questions, and then stop, analyze, think, make a report of everything that you have learned, and select the possible solutions that you might have to solve the problem. Okay, and when we find that, when we reach this moment, then we can go to the next phase, and the next phase is really acting. And acting means that there are evidences that you have possible solutions to be developed, to be implemented, and you have already engaged a large audience. So the problem is real, the problem is not unreal, and you have talked with people, you have asked questions to people, so you know that is a real problem that you have to solve, and there is a real audience that then will evaluate your possible solution. And that's exactly what the students, I think they really like that. Okay, so by the end, we are all very involved, because we believe in our solution, and we want to demonstrate that our solution will make a difference and our solution will solve a problem that we have selected as a big problem, a big challenge. So at this stage, the students are really very engaged students and researchers, and they are really willing to prove their idea. They become owners of their own solution. It's really very interesting. Okay. So sometimes we have more than one solution, and sometimes we really need to involve other actors in the process to develop. For example, if there is a product to be developed, we need to develop a product, so we need to do other activities to really turn our solution viable. So here we do something more than we traditionally do in our classes, is that we really have a solution and now we need to prove the solution. So imagine, in the case of the ocean I'm going to show you, we have a solution to develop certain types of sensors to monitor some variables. So what we have to do, we have to construct the sensor and we have to monitor the variable and we have to prove that our idea is really working. So in an engineering course, this might need practical lab in which they will go and do and construct their own models and prove their own models. But then they will do this already in a scale that it's not a lab, university lab scale. This might be a little bit bigger depending on the project, depending on many different things. Then we can adapt this process for. It's very versatile, okay? So that's what I'm saying here. So after this, the solution concept, or the concept of the solution is really clear to everybody, maybe we need to develop prototypes, and maybe we need to experiment, and maybe we need to test. And when we do this, we do sometimes in the real world. And that's the challenge becomes much more rewarding for the students. As I said in the beginning, they do not react so easily. So they think this is a different exercise, but then as they start doing the exercise, they really become very engaging, very interested in the exercise. As I said, in the act, we are going to implement, and also something extremely important is the evaluation of the implementation of our solution. So we can invent solutions that goes nowhere, that solve nothing, or we can develop solutions that really solve a problem, okay? And then we need to measure how much did this solve the problem. And sometimes our students, from the classical teaching methods, they have no idea that the real world measures the solution. Is this a good solution, a bad solution? I think an excellent example is this COVID vaccines. In Portugal, when we start vaccinating people, we had 6 different vaccines, 6 different vaccines. And people were saying some vaccines are better than the others. When we start doing the second dose of vaccination, we just have 4 vaccines. When we did the third dose of vaccination, just 2 vaccines. I think that's a good example. That's at the beginning, there were several solutions because it was really important to have the solutions. But as the time goes by, some of these solutions are not as good as the others. So we need to measure the impact of the solution. Sometimes this is not easy. The other thing that we need to convince our students is that they are not alone. This is going too fast. They are not alone. So they have engaged a lot of people in the process. So all of these people that they have engaged in the process, they can help him to evaluate the solution. And that's something also interesting because they really work in a team, in a close team and in a large team, and they learn these skills. So my experience with this exercise, as I said to you, is relatively new. And I've been doing this at different levels, master level, and I am doing this myself and with some of my researchers, and the experience is really, really very positive. So when we reach to this point in which we found the solution, we prove the solution. So it's really time to document, to reflect, and to share, to present. This means what? Of course, you may write a scientific paper, you may write a patent, you may write a report, but you should show it to the world. You should show it to the community. So in our classrooms, what we do is we ask the people that they have engaged during the process to be in the auditorium or the classroom in which they present their process, okay? And interesting to see if when we engage companies, it's really interesting, even for the students to get a job in the near future, because they really present themselves to their future employees. And this is something that really they also like, especially if they are finishing their graduation. And that's another good outcome of this process. Okay, so I think I explained reasonably well how the process of challenge-based learning works. I will repeat, there are 3 phases. The first phase is really engage. After that phase, we stop and evaluate if the exercise is done with students. Second phase, we investigate and we go deep in the knowledge of everything related with that. We stop, we report, and we analyze, we pick up a solution, and then we move to the action, really implementing the solution that we have proposed, and then we evaluate the output of this implementation. And I think that if you stop and think this is real life, that's exactly what companies does. That's exactly what we do in our normal life. So that's why this process is so well perceived by the students. Okay, I hope this works. I have a very short video, 4 minutes of video from the European Consortium of Innovative Universities, in which this has been really implemented by a couple of number of universities that belong to this consortium in Europe, in which the University of Aveiro, and Aditya knows very well this consortium. Okay, let's see if this works.
The challenge-based learning framework is divided into 3 interconnected phases: engage, investigate, and act. Each phase includes activities that prepares the learners to move to the next phase. Within each of the phases, there are opportunities for mini investigation cycles, and if necessary, to return to an earlier step. Supporting the entire process is an ongoing procedure of documentation, reflection, and sharing. In the engage phase, the learners start with an abstract big idea. A big idea is a broad theme or concept that can be explored in multiple ways and is important to the learner and the wider community. Examples of big ideas include resilient communities, energy, sustainability, circular economy, mobility and transport, and extreme weather. Based on this big idea, the learners generate a wide variety of essential questions to elaborate the complexity of the big idea and which reflect the personal interests of the students and the need of the community. Who are the stakeholders? Why is this important to me? Where does this concept intersect with my world? Why is it relevant to work on this problem? Based on these essential questions, the learners define their actionable challenge, a concrete problem definition that is a call to action to learn deeply about the subject. An actionable challenge is immediate, realistic, and builds excitement. In the second phase, investigation, the learners begin with formulating guiding questions. Questions that include everything that needs to be learned to really understand and analyze the actionable challenge and develop an informed solution. Based on these guiding questions, the learners define and find guiding resources/activities. Any resource or activity that helps answer the guiding questions. Examples of guiding resources include courses and online content, databases, textbooks, and social networks. Examples of guiding activities include simulations, experiments, projects, problem sets, research, and games. Once all of the guiding questions have been addressed and the results of the guiding activities recorded, the learners continue with the step synthesize, where they analyze the accumulated data and answer all the guiding questions and build a foundation for possible solutions. In the third phase, ACT, the learners begin developing solution concepts. Solution concepts are sketches of possible solutions to their actionable challenge, including relevant criteria. After the solution concept is approved in consultation with the stakeholders, the learners develop prototypes, experiment, and test in the step solution design. This iterative design cycle will, in some cases, raise new guiding questions, require further research, and swing them back into the investigation phase. After developing their solutions, the learners implement the most appropriate one in real life, measure outcomes, evaluate on what worked and what didn't, and determine their impact on the challenge in the step implementation and evaluation. When implementation is complete, learners can continue to refine the solution or develop a completion report and will share their work with the rest of the world. It is very important in challenge-based learning that learners document all experiences in every step using audio, video, images, and photography, and also reflect on the steps taken, their cooperation, and their learning. The ongoing collection of content and documentation of the learning process provides the necessary resources for this reflection.
Okay, I think this was quite clear, and this is available. Sorry, need to move on. So, yeah.
The challenge-based
Sorry, we will stop this. Okay, so I think I presented the exercise. Maybe I'm giving too much information at the same time, but I think that I can share all of these documents. None of these documents is private, so I can share this. And I can also share with you, if you are really interested, in some of the websites in which you can find much more information. Currently, there's a lot of people using this exercise, not only universities, others, including companies. They are now doing this when they want to develop a new product. So, and if you really want to develop a new product, either you create the need for the product or you try to understand what is the need for the product, otherwise your product will not be successful, okay? So now I'm going to do the concrete example, and this is to share with you. I'm doing this as a researcher, so that's why I pick up this example. I could have picked up the examples of my students that we are doing in a classroom, but I wanted to show to you that this is also a very important exercise for researchers. And for me, this has been very, very fulfilling. So what I'm going to show with you is an exercise that I'm participating in, okay? And that's the example of the ocean. So Portugal is located here. And it is very interesting to see that first, we are quite close to the United States, okay? So that's the reason we have a big community of Portuguese here in this part of the world. Some islands here in the ocean are Portuguese, like Azores and Madeira. And also we are somehow an entrance to the Mediterranean, okay? So that's the Mediterranean, and that's an important, and there's a channel here that goes to this part of the world. So these waters are very calm. These waters are more calm than these waters. And if you go to Indonesia, you can, by boat, for example, it's faster to use the Mediterranean route than going through South Africa and the Cape of the Torments that it's difficult to cross. So this is really a route to the east. Okay, so if you look to Portugal, there's a lot of waters. We are more water than land. And so the ocean is really becoming important for many different reasons, and really see what I was just saying. But also interesting is that the north part of the Atlantic is very well monitored, but the South Atlantic, it's not so well monitored. Maybe this is related to the fact that these countries belong to Africa. Some of them are not so well developed, some of them are not rich. So the controlling of these waters is almost non-existent. Geopolitically, this is extremely important. So the ocean is something really, besides all of these environmental changes, etc., is something really, really important. Also, we are getting food from the ocean. So fishery is very important to Portugal, as it is to Indonesia. So there's a few things associated with the ocean that we should be really taking care. So for us, the big idea was the ocean. What is going on with the ocean? This was really the question that we start putting. So what we have done in this engaged process was talking to much people as possible, engaging a lot of stakeholders to try to understand the ocean. And I've discovered innumerable things about the ocean that I never thought. As a Portuguese, as a scientist, as an engineer, I never imagined that the ocean could be the source of so many interesting things, and also including scientific knowledge. And also the ocean needs action. So there are actions that we can do to, to live very well together with the ocean, okay? So during this engage process, we had this idea, okay, let's talk about the ocean. Then we select a couple of important questions. What is really needed for the Portuguese waters? Of course, I'm Portuguese. We started to talk about the Portuguese waters, but then I realized that the problem of the Portuguese waters are not only Portuguese waters, are general waters in the world. So we start by selecting a couple of questions. What really these waters need? What is already there in these waters? What kind of information people want from these waters? What should we protect? You know, this kind of thing. And then a challenge, I will show you. We talked with many people that I've never talked before. So we talked with the Navy, we talked with weather control, we talked with the governmental divisions responsible for the ocean. We talked with port activities. We talked with water control division, scientists, fisheries, fishermen, fish farmers, beach authorities, boat manufacturers, supermarkets because of the food, etc., etc., etc. And we have a couple of questions we were asking, a lot of questions. And after being completely flooded with questions and responses, we select two important issues for this country. Of course, I'm talking about the Portuguese waters. One is the industry of bivalves. And there's a problem, by the way, there's a lot of problems with bivalves. So the market of bivalves is increasing tremendously because people is now eating more bivalves than big fish. And that's, you know, one of the challenges of the 21st century. Young people is very aware of the ecosystem, so they don't want to eat big fishes because they think we are killing the big fishes. So they need the nutrients of the fish and they feel better in eating small fish. I was very surprised with this, but that's the reality. So bivalves industry is increasing, and that's a good market for the Portuguese. So the bivalves industry requires a lot of things and what they want. So we ask them, really, what do you want? What is the solution that you would like to have? And they said to us what is written here. They need a quality control of the water based on detections of toxins, virus, and bacteria. And they want it to be in situ, and they want to real monitor in time. to be able to predict what is going to happen to these bivalves. If there is a toxin coming, if there is a virus coming, if there is a change in the temperature and then some bacteria develop, they need to control this on a daily basis. Currently, they control ex situ. They take a little bit of water, they measure the quality, and that's it. They don't that. They want to measure it, you know, in situ, constantly, monitoring constantly. So they don't have this solution yet, and they want it, because then they acquire the data, but then they need to save the data, analyze the data, and then doing the data management. So this is really a challenge. The other challenge that we found that was very interesting is associated with these buoys. Okay, you are a country, so that's why I also choose the pickup of the ocean. I think you understand very well what is the ocean. In your case, you also have these things associated with the earthquakes, as we also do in Lisbon. So there's a lot of things that we really need to control in the ocean. So we have these buoys, and you can see this one here is interesting. You see already here some solar panels, you see? So now buoys are very sophisticated. This buoy here is just to measure temperature, wind and temperature, but that's not enough. So now they want buoys that measure, again, that acquire data like temperature, pH, and even, I would say, all of things associated with the waves, and something associated with the viscosity of the water. There's a lot of things that they really want to measure. Again, they want to measure, but they want to measure in situ, at open ocean. If in your case, you have a kind of a very mild ocean, but in our case, Atlantic Ocean, it's might be very, very rough. So what is happening to these buoys? Sometimes they disappear, and each buoy of this may cost 5,000 euros or $5,000. So what they want low-cost buoys, self-powered, because these solar panels, they require batteries, and it's very difficult to go to the open ocean to change a battery, because then it's difficult. So they want self-powered, and they want to be able to measure everything. Satellites to control fish crowds, satellites to control boats, satellites to control submarines, satellites to control everything possible. That's what they want. Real-time data acquisition, data management. I was really surprised, and I think that's quite interesting, these needs. So after contacting with all of these people and having these ideas that the bivalves community and the buoys community have these needs, we really create the knowledge to find a solution. And our solution is associated, the one that we really came up with was with, in this case, that is interesting to me, is flexible electronics, low-cost sensors that we can apply to either the bivalves industry and also to the buoys. So we are now developing sensors that are self-powered, low-cost, based on biodegradable materials that then, if they are lost, they are lost. They will not damage the ocean as the others, usually silicon-based, does. Okay, so I really wanted to share this knowledge with you, because in the phase of, I would say, engagement, we really select the challenge. In the phase of investigation, we learned a lot about bivalves. Never in my entire life I've studied bivalves. Now I know a lot of bivalves and why bivalves are important. Although bivalves is not exactly my research field, I can use my research as, I would say, materials for microelectronics to be used to help bivalve industry. And also we team up with electronics, because we also don't know anything about acquisition of data and managing data, okay? So this is really a multidisciplinary team that will come up with this solution. So we will develop flexible electronics, we will develop devices that are based on piezoelectrics, and we will harvest the energy from the waves to be able to power the satellite panels that they require. So these are our, I would say, solutions, and the Navy is quite excited. So what we are now doing is in the phase of acting. So we are developing our prototypes. We found already companies that we will work with us. We are writing proposals to get fund to develop these materials. And I think by the end, we will come up with a nice prototype to at least to help some of these challenges. Okay, so I've been talking for a long time now. I just want to summarize, and I leave some time for the discussion if you really want to interact with me on based on my experience exactly. So I really want to summarize a little bit here by saying that we as University of Aveiro, we belong to this European consortium of innovative universities, and challenge-based learning is being adopted on a more generalized base than it was in the past. And this challenge-based learning was developed by Paul McIntosh many years ago, many years in the beginning of 2006, I think is the first exercise they did. They did it as a purpose to develop a product. And from that moment on, the concept of challenge-based learning has evolved for high schools, universities, companies, different institutions can use this process. This process can be divided in three main phases. Phase one, engage. Identify the big idea, identify the essential questions, and identify the challenge, because we cannot solve too many things at the same time. One thing to be solved, a challenge to be solved. After phase two, we entered in, after phase one, we entered in phase two, investigate. Go deep, deep, deep as much as you can in that problem that you want to solve. Read, analyze, try, and always talk with your stakeholders. They will help you to say that solution is not feasible. There's already a solution for your problem, okay? And document is very important, to document. After that, you are able to brainstorm in your team and find a solution. Pick up the solution, third phase, act. Implement the solution. Test the solution. Talk with people just to see if your solution is really implementable. Then go to the implementation of the solution and then evaluate. And you finish your exercise. And then you present to the world, oh, that's my solution for the problem, okay? So this has been a very interesting exercise to me in particular, and that's why when Aditya asked me if I would be able to share this with you, I'm very glad to share. My experience is relatively new, so I'm not one of the most knowledgeable persons, but I really feel it as a very powerful technique to engage my students, because giving classical classes to master students and PhD students, it's not so easy. So using this exercise is easy. So if Aditya will give me a little bit of moments, I quickly will say something about the university for those of you that are not so familiar with us. So as I showed you, we are in Portugal. We belong to one of the European consortium of innovative universities. So we are relatively small and I think quite active. We are there located. So this is Portugal, and this is the capital, Lisbon. Second big city is Porto, sorry, and we are located here. And our location is really, really close to the ocean. So that's why this is very important. So Aditya, you still remember some of these images of the city and images of the salt ponds that are very important to us. So water is really very important to us. Is a way of living, as you can see here. And some of these salt ponds now are bivalve farms. So that's why The industry of bivalves is really increasing because a lot of people in the world is eating bivalves currently. So these are the beaches, and these are the university. As you can see, we are flooded by water. Really, water is very important to us. Some of the beaches we have with this amazing ocean, we also have an important port, and the port is used for our industries. We have shoes industries, ceramics industries, plastic industries near the city, and they export via the ocean. So we have an important port here. So we have to live between industry and port activities and fishing and also beach, because people, as you, like to swim and go to the beach. That's the university, that's our building, and that's the university. So we are always open to welcome people. So if you want to exchange, if you want to visit us, if you want to come here, please do it. We are always looking for good partnerships to be part of our university. Other images of the city, of the university and the new buildings that are ongoing. We are always ranking ourselves, and not sure if it's one of the most news or current rankings, but it's one of them in terms of material science. That's where I'm coming from. This is one of the most relevant university in the country. There is no other way of saying this. We are small. This is in general. So what I'm showing here is the first position in all of the universities, and we are always competing with the universities that are located in the capital. But in terms of material science, we are indeed the best one in all of the rankings. So the research is, as Aditya knows, the research is associated with the Materials Institute. It is called CICECO. We already have 20 years now. We are commemorating the 20th anniversary, and we have a new direction and a new board. And currently, I'm a vice director of this institute in which we do research. We are more or less 5,000 researchers, and we really do material science research. And some of the thematics that we studied: sustainability, biomaterials, materials for electrical and energy applications, materials for information communication technologies, life sciences, health. And then we have all of these lines, and my research is here associated with ceramics, electroceramics, sensor actuators, all of these things. Okay. In my case in particular, as I said, we work in electroceramics, and we are very worried with sustainability. We are moving fast to these flexible electronics and everything that is biodegradable. We have works now currently in exploiting polymers based on, for example, shrimps, because the skin of the shrimps has chitosan, as you know, and chitosan is a biodegradable plastic that can be made and composite with other materials. And we are thinking in using these chitosan-based plastics for the sensors that we want to really use in these buoys. So I'm giving you information on what we are doing. So mainly my research interests are focused on materials for electroceramics, dielectrics, non-dielectrics, piezoelectrics, and ferroelectrics. We fabricate different shapes. We apply in very different areas, including bio applications like tissue engineering, using all of these properties. We study very different types of materials, from oxides to inorganic materials. And we are also very worried with the sustainability and industry processing. So trying to look for really low energy processes to produce the materials. Because as you may know, Europe wants to be CO2 free, in completely zero emissions by 2050. And either the industry develops processes to do that, or it will be impossible. Something relatively new from 2018, we have a makers lab in which we have our printers. And now currently we print almost everything. And that's something really important for prototyping and also for researching. So some of these sensors that we are currently developing, we use different types of additive manufacturing process in our makers lab. And I will leave you with some information about Portugal and information that you may want to dig just to know if you have opportunity to come. There's a call. This one is from last year. I forgot to update it, but there's currently a call for PhD students funded by the Portuguese government. So if there is any interest, you may always contact it with me. So thank you very much. And I think I stop here.
So thank you, Prof. Paula, for a nice presentation. And it's time for the participant to ask one or more questions to Prof. Paula. Even though the topic is not really exactly with the case study based learning, but I'm sure that this challenge based learning is the it's a kind of a big term of this one of the learning method. For example, case study or project-based learning method. I think it's included in this challenge-based learning method. And the interesting one is how Prof. Paula engage not only with the student in the class, but also people outside the class, maybe the practitioner, the community, to find this, to find and to select this big idea into the real one, into the challenging one. So maybe we have one question from Mr. Tiara Triana. Sometimes when students are in charge for solving a case, sometimes they will be understand only on that particular topic. What are your tricks to anticipate that? So maybe.
Yeah, I think this is a very good question. So just a comment before Tiara Triana, I will answer based on my experience. Yes, Aditya, I think you are right. So challenge-based learning is a platform, and then within the platform, you really can study or teach and learn case on a case based. I think that my university is really interested in the challenge based learning process because it somehow simulates the current needs of the society. So that's why it's becoming so important, particularly for engineers, because companies are now somehow lacking creativity in the sense that engineers really need to develop new solutions for new problems. And that's why this challenge-based learning, it's really a challenge. And sometimes it's difficult to start, but after starting, I think the results are really very powerful, as I mentioned to you. So I'm doing this with my master students, my PhD students, and also my researchers. So 3 different levels of the exercise. And I think it's a quite nice platform. Also, this requires that we as professors, we as I would say mentors, we also need to change a little bit the way we do it. Because naturally, when I go into a classroom, naturally I start talking. And that's not exactly the objective. The objective is that they talk to you. And, you know, so it's a kind of an adaptation from all the parts. It's very interesting. Okay, so now trying to answer to Tiara Triana, the question is, I have it written here in the chat. Sometimes when students are in charge of solving a case, sometimes they will be understanding only on that particular topic. What are the tricks to anticipate that? And this is a very nice question. Thank you very much, Tiara Triana, because I think this is exactly what allows me to say that this challenge-based learning process is so powerful. Because when you choose a big challenge, before choosing the case, you have the big picture. So they will be very confused at the beginning, like lost, because there's so many things they are tackling. But now, after some time, they have this broad knowledge. They can really focus on a particular topic, but they will do it knowing a wider, I would say, in a wider situation. That's why I feel is very, very important. And for me as a researcher, this is really important, because sometimes as researchers, we are even worse than students, because we go and dig on a certain topic. That's why we are a researcher, right? Because we really know a lot of that topic, but we will benefit more if we know the wider problem. So tricks to anticipate that. It's exactly, or suggest your students to go back and try to understand how this particular topic is related with a big challenge. So try to deconstruct in order to understand how impactful this can be on a larger scale. Then they will be more knowledgeable to go to a particular topic, because it's exactly like that. Students tend to go to a particular topic and then they just know about that. And the reason is because they are afraid of, they feel that they don't have the knowledge and they don't know where to get the knowledge. So that's why the engaging others, the engaging the stakeholders is so powerful, because they will get information from all. And as you know, our brains are like sponges. So the knowledge is around and we absorb it and then we digest it. And that's the process of engaging. So my suggestion to you is try to engage the students with more stakeholders, with more people, to see a wider view before going to the topic. That's a natural behavior of the students and from ourselves. Thank you for the question, because I think it's very relevant.
Okay.
Aditya, any other questions?
Yeah, we have another question, please.
Okay. Rakanita.
Okay, maybe another one.
Did you write it or you want to, because I'm not listening to the question.
Yeah, it's in the chat room. Usually for a class from Mr. Fajri Ihsan, usually for a class, we just have the limited time. How to get this complete and deep learning in the limited time?
Okay, that's also a very good question. So thank you very much. In our case, we have this Bologna system and this ECTS, so this system of credits. And the students are credit. So the system is based on independent study. So the class time is not relevant. So there's another difficulty, is the students need to understand how to manage their time. So in the exercise I'm doing with master students, we don't have regular classes. There are no regular classes. So what we do is, imagine that I have 3 hours per week. I meet with them every week, like half an hour to 3/4 of an hour. And I really meet them personally and talk with them, try to solve their needs and give suggestions. The rest of the time, they will work by themselves in the classroom, in their groups, and they work, they dig, they question, etc. Every week, they write a small report. So the team leader needs to send me a small report, like half a page or one A4 page, that I monitor, control. They are talking with me almost every day, by email, by different ways. I'm always facilitating. So for us professors, we need to be a little bit more available. We really don't have that class time. What we have is this open platform of communication. And as I said, I meet with them, but then I leave them. They work by themselves. And that's the way we do it. But of course, and also you are right, because the time is very limited. We cannot be trying to solve all the problems possible. We have to tackle just one, and then we have to guide them, because naturally they tend to be lost within so much information. They will get lost very easily.
Okay.
Any other questions?
So I have one question.
Yes, please, Aditya.
For the exam,
How they are evaluated, right?
We have a written exam, midterm or final exam.
Yeah.
How about that?
Okay, thank you for your comments. Amazing, Professor Paula. Thank you very much. This is very nice. Thank you. So Aditya, the evaluation process is really, really very important. So I will pick up the slide again. Okay, so let me move my bar from here. My bar here. Chat is here. Okay, so now I can see. So you see here the process. So as I said, 3 phases. Phase 1, engage. Phase 2, investigate. Phase 3, act. So after each phase, they will be evaluated. And how they will be evaluated? They have to write a report. Okay, so it's a short report to tell us what they have been doing. As you saw in my presentation, there's a slide in which I say all records are important, like emails, like photographs, like videos. They have to report everything they are doing. So we have a collection of information. Some of them, they even make small movies when they are talking with people. Imagine they go to a company and they talk with the company, they make a small movie. So these are all elements of evaluation, okay? And they know that they have to be evaluated after this part. And this evaluation, for example, is 20% of the final mark. They know, okay? And they know this before going to the second part. When they go to the second part, by the end, they will be again evaluated, okay? And then by the third part, they will be again evaluated. Again, evaluated by what? By reports that they present. And in this case, by the solution also, because if the solution is very stupid, or impossible, or they didn't engage all the stakeholders, or they didn't talk with the right people, because some of students, we try to motivate them, but it's really a commitment. We evaluate their commitment and their knowledge, of course. Sometimes they, imagine a solution and they don't know that much about physics. They need to go to the physics professor to say, oh, can we solve this problem in this way? And this has to be reported. So as the mark will be higher as they engage more, as they prove that they have learned more, okay? So you can, and then finally, they have to write a report. So maybe 20-page report, no more than that, with all of this information that have been collected, and they have to make a formal presentation to a table of professors and other industry and others, they will be questioned and they will be evaluated on an individual base. There's an individual mark, it's not a group mark, that is a summation of all of these parts. So in some cases, there is not a written exam. It's a very, I would say, regular evaluation. And that's another thing they like, because they like to have our feedback. As they move, they like to know if they are doing well, if they are not doing well, and what is the problem. Sometimes students are difficult. There are some students that are really difficult in the sense that they don't want to go out of the classroom. They don't want to talk with people. They don't want to make phone calls. They don't want to do that. They just want to be sitting there waiting for the lecture of the professor. There are no lectures, as I said. We start by explaining the process to the students. The way I'm using some of these slides I use to my students to present them the process. And then I meet them every week in the class time, half an hour, 3/4 of an hour. Then they go and they work. And when they are lost, they come to me, they visit me many times. They send, every day I have emails from the students asking things. Can I talk with you? Can you suggest me? Can you do this? Can you do that? It's really a teamwork, but it's interesting. Okay, Aditya, did I answer to you?
Yes. And during the presentation, you said that maybe in the stage of engage, or in the stage of act, you involving maybe a practitioner, maybe industry.
Yes.
To seek the big ideas, the challenge, the problems, and then this industry or practitioner, they evaluate, they evaluate the action that proposed by your students.
Yes.
And how to deal with this stakeholder, because as you know, when we contact with the industry, sometimes they don't have interest, they don't know how about this kind of method, for example. Do you have any experience with this?
Yeah, that might be a problem. So how can we solve that? So that's exactly one of the things we do in the classroom. At this university, we work quite close to the industry, quite close. So I think we have a bunch, I would say, a reasonable number of companies that we may contact with. Okay, so it's like a portfolio of companies that we regularly work with. This is one thing. Second thing, and that's my job, you see, that's my job as a professor. I have to establish the contacts with the companies. So I use my own contacts, but I also use the contacts of the university. And if it is necessary, I pick up the phone and make a phone call and say, look, we have here a problem, a challenge-based learning process. Are you available to talk with these students? Not. We can. My students also use European industries outside of Portugal. So if they need something. So up to now, it has not been a problem. Also, I should say that the Portuguese industries are really changing their minds. They really understand that development and innovation will be based on science. So they really are now talking with the universities on a more regular basis. You know what is happening to me currently? Every week, I have a meeting with a company, almost every week. And it's not only because we have common projects, but it's also because they are receiving our students for masters, you know, for industrial projects and things like that. So up to now, I've not been facing any problem in engaging the industry, at least in Portugal. But as I said to you, I use different ways of going to the industry. Also, I ask my colleagues to facilitate. Sometimes, you know, my specialty is more related to the ceramics. If I need something to the industries associated with polymers, what I do is I contact one of my colleagues and said, look, I need this information. Can you give me a contact? Really, what the thing that the students also like is that they are starting creating their own network, you see, and their contacts, and they become really very excited in talking with the industry, because they will be, by the end, if these are in the industry students, by the end, they will be the future possible employers. So they also learn how to create a database. Okay, I'm doing this with almost ending students. I'm not doing this with these first year level students. I don't have that experience. I just, as I said, I have experience with master students, PhD students, and researchers, not the very first. I think if we do at this first year at the university, this needs to be adapted, because they don't have, they are far away of their ending. In this case, master students are almost to go to the industry. So they even by themselves, is really surprising, Aditya, how powerful your students are. If you challenge them, they really respond. That's another discovery I've done with my master students. You challenge them. Not all, of course, it's not all. We have not so good students, we have medium students, we have good students, we have brilliant students, but the majority of them, they surpass themselves. They like the experience. And look, students are very critical, as you know. They are very critical towards what we do. And in my university, everybody's asking them, by the end of the semester, they have to write down a report about the topic and about the professor. And they are very cruel. If they don't like you, they don't like you. And that's what it is. But in my experience is that they are very powerful. They are a source of energy that is really incredible. They do amazing things when you let them, when you trust them. That's something my experience is. Then, so that's why I like this kind of teaching a lot.
So I'm asking again for the participant, please, if you have a question to Prof. Paula.
Okay, so
Rakanita,
yeah.
Yeah, please, Rakanita.
Yeah, okay, thank you, Mr. Aditya. Thank you for Mrs. Paula for the extraordinary presentation, and to Mr. Aditya as the head of the Department of Metallurgical Engineering at Sultan Ageng Tirtayasa University, and who I respect the audience for this afternoon's webinar at Indonesian time. I'm Rakanita. I'm former student majoring in metallurgical engineering class 2017. I have a question. Maybe it's agak not okay. Sometimes when I work, there are some things that need to be learned again, but in this case, I really don't like it, and it causes me to be lazy to study it. What do you think, so that I can still study well? Because I don't think it has a good impact on my integrity. It's my question, Aditya.
Okay, thank you. So, Prof. Paula.
I'm not sure if I understand the question, Aditya. Can you rephrase the question?
Yeah, maybe as I understand, Rakanita, she asked after her graduation, maybe at
Yes. sometimes when I work, there are some things that need to be learned again. But in case,
yeah,
I really
yeah.
don't like it and it causes me to be lazy to study it. What do you think so that I can still study well? Because I don't think it has a good impact on my integrity, Miss.
Let me see if I understood the question. So you are already working, right?
Yeah,
Okay, so you are not anymore a student.
yep,
Okay, good. So, and if I understood properly, this means that in your real life, you are feeling that you need to learn more, or there were some topics that you didn't learn. Am I correct or not?
Yeah,
yeah,
there is maybe one kind of job or skill that she doesn't like to
teach.
to to learn it, Prof. Paula. But maybe
Yeah, I'm not sure if I'm